Okay, we're going to move to the other side of the quadrilateral family tree. And so we're going all the way back up to quadrilaterals here, because what we're going to add over on the right or the left-hand side, I don't know if I'd say they're opposites of what's on the right, but they don't overlap to each other. Okay, so let's fill the titles in and then let's go back with the properties. So the first bubble right here is going to be the shape kite. Okay, so, you know, like you would fly a kite, there are properties of a kite. It is considered a type of quadrilateral. And then let's move way over here even further to the left. The first one here will be trapezoid. Trapezoid. And then underneath trapezoid is a more specific type of trapezoid. That's going to be our isosceles trapezoid. Let's do this one. Okay, this is going to be isosceles trapezoid. Let me zoom out here. That's going to be a little bit hard to read. All right, may not be able to fit it all in the bubble. Isosceles trapezoid. Oops. Okay. So let me start with kite. Actually, I take that back. We're going to start with trapezoid because we start with trapezoid in our notes first. Okay, so the main, I guess, I'm going to start with, I always start with the definition as number 1. So in a trapezoid, what makes a trapezoid different than a parallelogram is it only has one set of parallel sides. So I'm going to add here one pair of opposite sides are parallel. One pair of opposite, I'm going to say here, opposite parallel sides. Now, if we have two sets of opposite parallel sides, we no longer have a trapezoid, we have a parallelogram. Another one that we have here are the consecutive interior angles are supplementary. Consecutive interior angles are supplementary. I mean, I guess you could just say the consecutive angles are supplementary, but I'll talk more about that in a minute. So I actually want to go back and forth between this paper and our notes packet because I want to elaborate and give you a visual of what that looks like. Okay, so we've got one pair of opposite sides are parallel, and then consecutive interior angles are supplementary. So I'm going to switch over to the notes packet. All right, so I want to start with this diagram and add to it and, you know, compare it to the properties we just wrote down. Okay, so here is a trapezoid. So I want you to label some vocabulary here. Well, first of all, let's put on the parallel side. So in this particular trapezoid, I have the top and bottom are parallel. So that's the basic definition of a trapezoid. One set of opposite sides are parallel. Now, we have some vocabulary here. So the two parallel sides are called bases. So I'm going to write base above the top one, base above the bottom. The non-parallel side are called legs. So in this picture, the left and the right are the leg. Now you can rotate this trapezoid around. It doesn't have to always look like this. Now we have a set of angles, and it can be a little bit confusing, but if you look at the base, at the end of the base are two angles. These angles are considered a pair of base angles. Okay, so I'm going to write here at the top, base angles. And I'm going to point to this one, and I'm going to point to this one. So they go together as a pair. Got the same thing going on at the bottom because there are two bases. base angles. So along one base are a set of base angles. Along the other base are a set. Now, this angle here and this angle here are not considered a pair of base angles because they don't belong to one base. So here's what I want you to see about the second property of a trapezoid. Since I have parallel lines cut by a transversal, let me switch colors here. This angle and this angle are supplementary. Okay, and that just goes back to parallel lines, but it's a property of a trapezoid because we've got parallel lines here. Okay, so those two angles add to 180, and the same with the other two on the other side. Okay, so those are the main properties of a trapezoid. Now we can get more specific with isosceles. So we're going to draw another picture over here. And so I'm going to draw the same type of trapezoid. Oops. Try to make a straight line. So this is going to be an isosceles trapezoid. Okay, so let's name it ABCD. Okay, so in an isosceles trapezoid, it still has all the properties of the trapezoid we just listed over to the side. So it has one set of parallel lines. The other item that makes it isosceles is the two legs are congruent to each other. They're the same length. So in just a general trapezoid, the two legs don't have to be congruent. Like, for example, what if I gave you this trapezoid? Maybe where these are 90s. So this is still a trapezoid because the top and bottom are parallel, but these are clearly not congruent. Okay, so in an isosceles trapezoid, the legs are congruent. The other thing in an isosceles trapezoid is the base angles are congruent to each other. So I can put an arc on A and an arc on B. Those base angles are congruent. And then D and C are a different set, so they're equal to each other. Now, A and B are not equal. They're supplementary to each other. If A and B were the same amount and D and C were the same amount, then I would just have a rectangle. Because if these were congruent, they'd have to be 90 because they also add to 180, which makes that one 90 and that one 90. So we no longer have a trapezoid. Okay, so let's switch over to the quadrilateral family tree and add some of those properties. And then there's another one about diagonals that I'd like to talk about. Okay, so notice that isosceles trapezoid is under trapezoid. So both of these properties apply, and we have three more. Let me get back to my color here. All right, so characteristic number one is kind of the definition of an isosceles trapezoid is that the legs are congruent. And I'm going to use the congruent symbol. Okay, legs are congruent. Then the base angles are congruent. Okay, so I'll go ahead and draw just another real quick picture here. Isosceles trapezoid, okay? Parallel. Legs are congruent. Base angles are congruent. And then the last property is about diagonals. So if I were to add a diagonal here, and I were to add a diagonal here, the whole diagonal is congruent to the other diagonal. Okay, so I'm going to say here diagonals are congruent. Lots of congruent items in an isosceles trapezoid. So they don't cut each other in half. They don't bisect each other. But we do have an interesting effect here when we have an isosceles trapezoid. And so we'll get to an example here with some of that in a minute. Okay, that covers trapezoids. So I want to go back to the notes packet. Let's go through some examples about trapezoids, and then we will switch over to kites. Okay. we do have a theorem for a trapezoid called the mid-segment theorem. So let's draw a picture first, and then we'll add to it. So let's just draw a trapezoid. I'll draw one that kind of looks like this. Maybe draw the top a little bit longer. Okay. And so if it's a trapezoid, let's add the parallel marks. And then let's go ahead and name it. We'll just do A, B, C, D. That might be helpful in our explanation maybe. Okay, I want to draw a mid-segment. So a mid-segment is a segment in the middle. Okay, so I'm going to put a segment right here. And so I'm going to call those points E and F. All right, so the mid-segment, think about segment in the middle. It has several properties here. It is parallel to each base. So that means that I can add a parallel mark here, okay? And then its length, the whole length of EF, is 1/2 the sum of the lengths of the bases. So let me come back to that in a minute. The other thing the mid-segment does that isn't in this theorem is it bisects the sides. It bisects the legs. So what that means is AE and EC are the same length. BF and FC are the same length. Now, if this is an isosceles trapezoid, then these two legs are the same, which means these pieces are all the same. But in just a regular trapezoid, that's not necessarily the case. Okay, so let's go back to the length one. The length of the mid-segment is 1/2 the sum of the lengths of the bases. So let's use this with just the names. So the length of the mid-segment, EF, is equal to 1/2 the sum. So I'm going to add together the bases. AB plus, oh, I just noticed I did A, B, C, C. Let me fix this one down here. That should be a D. Sorry about that. A, B, C, D. That's a little better. Okay, let's go back to the formula. EF, so the length of the mid-segment is 1/2 the sum of the bases. So AB plus CD. Okay, let me give you a real simple example. Let's go through a couple of these. Let me change colors here. Let's do red. Let's say that AB, is, I don't know, 20, and CD is 10. So if you think about this formula, it's saying to add together the two numbers and take half of it. So that's basically an average. So if I were to I'm looking for the middle number between 10 and 20. So I'm going to have 15. Or you could do 20 plus 10, and then times a half. Okay, you could average it. Now, we are going to need to do that formula when we're dealing with variables. Okay, so let me back up here. Let's say we know that the middle is, let me think here, 6, and I know that AB is 8. Well, how long is CD? Well, if EF is in the middle and AB is 2 units above it, then I know that CD needs to be 2 units below it. Okay, so do you see how that works? So think about EF is the middle number, and you're going to average them. Now, if I have variables here, I certainly am going to need to work through this formula here. Okay, we're going to come back to that here in a little bit. Let's go on to example 1, and I want to talk about this trapezoid on a coordinate plane. So we're trying to show that this is a trapezoid, A, B, C, D, and so we're going to have to use some of those properties. So I'm going to use the basic definition of a trapezoid. So if I have a trapezoid, I need to show that one set of opposite sides are parallel. Need to show one set of opposite sides are parallel. All right, I'm on a coordinate plane. So in order to show lines are parallel on a coordinate plane, I need slope. Okay, so I'm going to use slope. So I'm going to take an educated guess that BC and AD look like they might be parallel. So I'm going to count slope. So BC, the slope, I'm going to use rise over run. So it's going down to 1, 2, 3 over 3. Do I have the same thing on AD? So I'm going down 1, 2, 3, 4, and then over 1, 2, 3, 4, 5, 6. Okay, but that does reduce to negative 2/3. All right, so BC is parallel to AD. Okay, let's make sure the other two are not. So this one I can see pretty well. So this is a vertical line and this is a diagonal line. All right, so they are not parallel. What I would do is I would actually show those numbers. So I might just go ahead and be consistent here. So 1, 2, 3, 1, 2, 3. So AB is 3 over 3, which is 1. Now CD is vertical, it's undefined, it has an undefined slope. So I'm going to say here, AB not parallel to CD. Okay, so therefore I have just shown it's a trapezoid. So these two things are going to give me what I need to show that it is a trapezoid. Okay. All right, let's keep going. Let's do some examples that are not on a coordinate plane for a trapezoid. So I'm going to refer back to your family tree. Okay, so I might switch screens here. All right, in the diagram, ABCD is an isosceles trapezoid. PQ is the midsegment. Okay, so I've got some information here. So since it's isosceles and it's the midsegment, each of these 4 pieces is equal. I've got parallel lines, and I'm going to add one more here. And I have some other information about angles that we will use in a minute. All right, find the measure of B. So B is right here. Okay, the opposite angles are not congruent in a trapezoid. If they were congruent, we would have a parallelogram. So what I'm going to do is come up here to A, and because A and D are supplementary, I can figure out the top angle. So this is 105. And because this is isosceles, these base angles are equal. So that means the measure of angle B is also 105 degrees. Okay, PQ, find the length of PQ. All right, so the midsegment, PQ, is equal to half the sum of the bases. Okay, so PQ is equal to 1/2 of the sum of the bases. Now, you might look at that and be able to determine what the number is. You're looking for the number halfway in between them. If you can't look at that and determine it, then just go through the formula. So half of 60 is 30. So that is the value of PQ. Okay, I'm going to stop here and make a second video about kites. So I'll probably do, I'll do